I'm Xandra DiRaggio. I am the Director of Mathematics at the Lastinger Center for Learning here at the University of Florida. Our center does a lot of different things, one of which is mathematics, and we do professional learning, we do research, and all kinds of things around the state of Florida and beyond. And I'm joined by some calm support, Maxine and Hope on the call, who, if you have any challenges, they can help. And then Amy, who does partnerships in our math team. So some of you might have interacted with her before. And then Jose, who is the manager of the math team here at the center. And if you've taken the math micro-credential, the Math Matrix micro-credential, he looks familiar because he's in a lot of the videos. So welcome, nice to see everyone. If you didn't catch part one of this series, it's okay. They are distinct and separate, and you can watch part one later if you wish. Today, we're really going to focus in on math discussions, which are one of the things that I always enjoy, but it's one of the hardest things about teaching mathematics is to have a really good math discussion. So hopefully we share some insights and ideas that you can take away, maybe even apply right after lunch today in your own classrooms. So we're going to talk about the quality of math discussions. We're going to talk about the teacher's role in this, highlight some math talk moves that you could use and you probably already are using. Maybe you just haven't heard them called that before. We're going to talk about questioning, and then I'm going to share some instructional nudges for Discourse that I think are a lot of fun and also helpful for getting students talking about mathematics. So here we go. I'll come back to that survey later. Quality of math discussions. So this is an opportunity for you to share in the chat before we get started. So you've all been participants in or facilitators of math discussions. So what does it look like or sound like, or what are the characteristics of a high quality math discussion? Like, how do you know that this math discussion is good and it's high quality? So what are you kind of listening for or hearing in your own classrooms? So you can put it in the chat. So what are kind of things that you listen for or notice about a high quality math discussion? Thank you, Marcia. So math vocabulary. So maybe you hear some precise language and some good use of math terms that is accurately used. Specific vocabulary, okay. Students defending their answer. I love that one so much. That is so important. Melissa, thank you. Students questioning each other as well as agreeing and disagreeing with each other. That is hard to do, but so meaningful when that happens. Participation, justification, math talk, lovely. So it sounds like it's not just kids saying answers to us. There's more than that, right? It's kind of like this interaction. There's justifications going on. Probably a lot of the MTRs, the math thinking and reasoning routines or mathematical practices are coming out in the conversation. Students are using vocabulary purposefully and accurately. Great. And I think I already alluded to this, but low quality math discussions, often you might just hear ping-ponging, I would say, like teacher to student, and then teacher to next student, and then teacher to next student. And most of the responses are pretty limited. They might just be the solution, an answer, a missing word. And there is a time and place for that, but maybe that's not the highest quality math discussion that we can have. Maybe a higher quality one would have more open-ended questioning, as Michelle put in the chat. Exactly. All right, so we're going to look at some strategies on how to do that today. So we're going to and if you've taken the Math Matrix micro-credential, some of this will look familiar, but we're going to go deeper. So math discourse kind of involves the teacher a lot, right? We're usually facilitating these conversations with our students. We kind of know where we want it to go. It's not just organically happening. There's stuff that we are doing consciously to foster this discourse. But when it's high quality and a good discussion, it feels like it just looks like magic. So I'm not a basketball player and I don't know much about basketball, but to me, it always just looks like basketball just happens. But it doesn't just happen. There's playbooks, there's moves, people have positions, there's all kinds of practice involved. The coach is facilitating a lot of these interactions during practice and stuff. There's a lot of planning and careful thought that goes into a basketball, I was going to say performance. I don't think that's the right word, game. And similarly, in teaching, when you're having a really good conversation, it's not like it's just spur of the moment. Probably a lot of really thoughtful planning went into that. So the teacher's role is central because it's so important to having a strong math discussion in your classroom. And then, the students are engaging in questioning with you. You're engaging with questioning with them. Somebody said this in the chat. If the students are questioning each other, that is amazing and so rare to see, but so important. And then the kids are also explaining their mathematical thinking. So there's a lot happening, and the teacher is responsible for a lot of that, even though it doesn't look like it when it's going well, because the kids are talking to each other more than they are just talking to the teacher. I'm going to start by just saying this whole series is built upon our aim of increasing math proficiency. So I'm going to very briefly revisit what I mean by math proficiency. I think it's really important that we're always on the same page of what do we mean by being good at math, being proficient at math. It is not just being fast and accurate at computation. There's these 5 strands of math proficiency. And if you want to catch webinar 1, we kind of went over these. But it's not just procedural fluency. It's not just being able to calculate answers. There's more to it. That is certainly one part of it. We want to be efficient, be flexible, know our procedures. But we also want to understand why things are working and understand math as patterns and connections, not just this is a rule, this is a rule, this is a rule, but how does it all work together? It's also about strategic competence, which I think I said this was my favorite one last webinar, and I think it still is. I might have said adaptive reasoning is my favorite, but I like this one a lot as well. So it's the ability to formulate, represent, and solve math problems. Like, how do I actually ask questions that I can mathematize and understand and investigate the solution to? That's really cool when kids start to ask questions and then we explore that as the focus of our lesson. So we want kids to start posing problems. We don't always want to be the ones that hold all the knowledge and ask all the questions. We want our students to take some ownership as well. And they should be able to translate it to real world solutions and useful representations, etc. Productive disposition, we want kids to like math and see it as useful. I think this affective feature is one we kind of don't concentrate on because it's kind of hard to measure. But we want people to like mathematics. We probably like mathematics. We've chosen to teach it or be educators. And we want our students to see like math is actually useful and kind of cool and creative. And finally, adaptive reasoning is very key to mathematical discussions, as many of you mentioned in the chat. It's explaining why something is true, justifying your solutions, seeing errors in reasoning, which is really important, and making logical arguments, which is one of the most fun parts about mathematics to me. So that's the kind of math we're trying to foster through rich mathematical discussions. Okay, so I'm going to come back to this every webinar because I think it's so important that we all see mathematics in kind of a similar way. All right, teachers' role in math discussions. So what is the teacher's role? What do you think of if you were coaching a new teacher, a novice teacher? Maybe you are a novice teacher and somebody coached you. Like, what did they say? What is your role in the discussion? What do you see as your main role in the discussion? And you can put it in the chat if you'd like. Thank you, Melissa. So a facilitator or guide. I'm seeing a lot of support for that response. Asking, guiding, open-ended questions, intentional problems. Yes. Guide their conversations, prompting, drop a question to push them forward. Yeah, kind of like invest in instigating kind of discussion. You're kind of saying like, what if this? Or have you thought about this? Or how did that sound to you? Yeah, you're kind of moving it forward. So that all seems great, but I think it's all a little nebulous still just to say you're a facilitator. I think it's helpful to say like, but what does that actually mean? What am I actually doing to facilitate? And tasks are definitely part of this. I'm just going to put a disclaimer out. The next webinar is about tasks. If you don't have a good task, there's not a lot to talk about. If I just say add 3 and 5, what are you going to talk about? You could talk about what you got for an answer. You could talk about maybe how you got there, but there's not a lot to talk about. If you said, what are different ways I can add numbers to make 5? There's so many more things we can talk about as a class. So I think tasks matter a lot. We're going to talk about that next time. For the rest of the day, we're going to kind of assume we have decent tasks that will facilitate some conversation. But given that, the teacher still has to do some stuff. So here's some specific things that you as a teacher probably are already doing, but I'm going to give names to it. So the math talk moves, probably some of you have heard about these already, and they're super helpful, and I use them all the time. And they're still not easy to do. I don't want to say because I can name them simply they're easy. Doing this is difficult work. It takes professional knowledge, expertise, and skills. So give yourself a lot of grace as you work on this and support your students, because having a really good math discussion is hard and kids don't get a lot of opportunities to practice it. So as you come into the classroom and you're working with your students, they need to learn what this sounds like because it's new to them often. And so we want to give a lot of grace to ourselves and to our students as we learn how to have these deep conversations. So the first one, and I think a lot of us do this, is repeating. So ask students to restate another student's reasoning in their own words. So Jose says something to me, and I say, okay, Jose, what I think I hear you say is this. Or I say, oh, Paul, can you tell me what you think you heard Jose say in that situation? So it's just kind of validating that they had an idea that was worth listening to, and that we're all going to take some time to listen to right now. And we're going to actually restate it, repeat it to make sure we got it right. So you're not just saying Jose says 5. You want somebody to say it in their own words. I heard Jose saying that he thinks the answer is 5. Did I get that right? He might even check in with Jose. So that's the first one, repeating. So a lot of times you'll say something, I do this in meetings a lot. I'll say something and nobody picks up on what I just said. And it's oh, that must not have been a very interesting or meaningful contribution that I had. But if somebody takes the time to repeat it, suddenly I feel like my idea might have been worth something, or at least somebody was listening to it because they listened enough to be able to repeat it in their own words, which is helpful. Okay, so in this instance, if you've not seen a which one doesn't belong, this is an opportunity where you can see one. Basically, there are quadrants like you see here on the right-hand side of this slide. And each image in the quadrant can be in or out of the set, depending on how you define that in or outness. And there's a great website, just Google or search which one doesn't belong and you'll find it. And they have lots of these. But you could have the situation where somebody says, I think the top left one doesn't belong because it's a gray circle. And so I might ask as the teacher, okay, does somebody want to restate or repeat what you heard Xandra saying? And they might say, she doesn't think it belongs because it's a gray circle. And then you say okay, is that what you meant, Xandra? So it's really just kind of reaffirming the answer, making sure people heard it, getting everybody on the same page about that strategy. So that's the first one. The second one, reasoning. So ask students to apply their own thinking to another student's reasoning. So for example, I'm going to do a lot of elementary examples just because they're on the top of my mind at the moment. But say that I multiplied 2 fractions, so a half and 3/4. Those are mean ones to multiply in your head. But I multiplied them and I drew an area model to multiply them to get my answer. Okay, so I might have explained it to the class. And then I might say, hey, Jose, do you think you could use Xandra's strategy to solve this other problem? That's all it takes. So you're saying oh, she had a strategy or some kind of reasoning. Could we apply it to this different task? That is hard to do actually, right? Because you have to understand their reasoning on this problem and then transfer it to something else. So you're trying to see if they understand it and can also apply it in another situation, which is pretty interesting to do and pretty hard to do, but it's a great move to use with students. Hey, we heard you doing this. Can you apply it to this situation? And I'm going to skip some of the examples because I really want to get to the nudges. The third one, adding on. I see this one a lot and it's very valuable. So Jose says something and I say as the teacher, does anybody want to add on to what Jose just said? Now, I have seen it, especially in kindergarten and first grade classrooms, where the kids will say, Yes, I agree. And also, last night, my sister did this thing, and you just keep going on, and it's not relevant to math. But the idea is you want them to get the experience of practicing and say, like, oh, I like that you did add on, but let's keep it about math. And you start to get these norms in your classroom around this. So the idea is you just add on to what they said and keep it related to what they said, not going out into wonderland with your responses, which is apt to happen. So, for example, you could give a problem like this. Would you rather have 312 Sour Patch Kids and give 187 to friends, or have 291 Sour Patch Kids and give 139 to friends? So maybe a student just raises their hand and says, I'd rather have 312. Often we might just leave it there and not do anything. But instead, what we could say is, Amy, would you be willing to add on to what Xandra just said and see where they go with it? If they carry it through to another place, do they kind of understand what's happening? You can also have students add on to their own thinking if they don't give you sufficient reasoning to go off of. So that's adding on. And again, I see this one a lot, and it usually works pretty well to get students to collaborate across different people. All right. Now, this one is a hard one, especially for teachers, because most of us like to talk, but it's wait time. I talk fast, as you probably noticed, and I also kind of talk as I'm thinking, but that's not everybody. Everybody is not a Xandra, right? Some people are really thoughtful and they just like time to process first. And if you have a room full of Xandras that just are blurting out really quickly, those folks feel like they can't contribute to the conversation because somebody else has already taken the floor. So, a strategy that many of us have learned and we forget to do sometimes is wait time. So, you ask a question or you pose a wondering or a prompt, and then you just wait. And wait, there'll be kids like me that will just shoot their hands up because we like to talk, but you kind of like acknowledge them by a look and then just like, oh, wait, I'll get to you. Let's let everybody think first. So wait time is really important to discourse because students don't all process at the same time and their comfort levels in reaction. Sometimes people like to rehearse things in their brains first. So, for example, multilingual students, if you were asking me to answer in Portuguese, which is not a language I feel confident in, though it's my parents' first language, I need time to think about what I want to say in English, then translate it to Portuguese, and then try to say it. Right. So I need wait time to contribute to the classroom. Otherwise, I wouldn't say anything at all. And I think some of your students may fall into that category as well, regardless of their language status. And these are all kinds of good things to think about. Like, how does this change the conversation? Maybe it opens it up to more students than just your quick, eager to answer and eager to please students. And how long do you decide to wait? Like, longer than you would think. I get uncomfortable and then I try to wait a little bit longer than I'm comfortable. And that's usually the right amount of time. Some people say I like count to 10 in my brain or things like that, but I don't think you have to prescribe it that much. But it's okay to be a little uncomfortable with the silence and then wait a little bit more. And then sometimes students will get uncomfortable and the ones that usually don't talk maybe even contribute because they just want the silence to break, which is also a strategy, I suppose. Um, and then during wait time, some students might just be like, gosh, I just want to say the answer. I know the answer. Some students might be practicing what they want to say, and other students might be still thinking, and that's all okay. We don't know, but the wait time opens the possibility for all those scenarios. And the final one is revoicing. So paraphrase what a student stated and then ask for clarification. So this is very similar to repeating. Repeating is usually you have another kid kind of say it and check in with the student. This one, you can kind of use them interchangeably. I do. There is some nuance there, but I think it's mostly not super important. Revoicing is kind of like you're restating in your own words and then asking for clarification. As a teacher, this one's important when students are using informal language and you want to bring in more formal language. So, for example, if I'm in a first grade classroom and the students are calling a square or rhombus a diamond, and I don't stop them and say, that's not a diamond. I might just say, I heard you say that you saw a rhombus, or I might interject the right vocabulary. Not that you can't say it's not a diamond, you can definitely say that, but sometimes it's nice to just restate it in the proper words because you know what they meant. They just aren't using the proper words yet. And so that's like a nice strategy that you can use and then check in with them and see if they're like perturbed that you called it a rhombus and not a diamond, and then talk about that. Okay, so before I go on, if you have any questions about the math talk moves, so these are specific things that you could do every day in your classroom to kind of get the conversation going. Put them in the chat or in the Q&A, and I'll make sure to get to those questions if you have them. If you have other math talk moves that you use and you want to put into the chat, I invite you to do that as well, because it's important that we share amongst each other as well. Okay. Questioning. So, what precipitates all these math talk moves and the discussion is like how the teacher is questioning the students, because usually a lot of the conversation is starting with the teacher. I'm posing a question, I'm asking students for input, etc. So, why do we pose questions? NCTM, the National Council of Teachers in Mathematics, kind of summarized 4 main purposes of questions. Sometimes you want to just gather information. What did the students know? Where are we at as a class? Sometimes you want to understand their thinking. So you probe their thinking, like, oh, I think this is what they're saying. I might ask more to understand what they're saying more fully. You sometimes want to make the math more visible to the student or to the class. Sometimes you just want them to think through something again or reflect or justify their reasoning. So there's lots of different reasons why we ask questions. So teachers should consider the task they'll carry out and draft a handful of questions that address these. So this is that basketball analogy, metaphor, analogy, I forget which is which, but that I posed earlier is that it looks like it's a great natural conversation, but really when it's going well, the game is going well in your classroom, you probably had some good questions in your brain ahead of time. So taking some time to jot down questions you might ask is actually quite beneficial to your lesson and to the quality of the discourse that happens afterward. In the math matrix, we kind of simplified questioning to think about it in just 2 different ways. Whether or not a question is closed or open is one of those ways. So closed questions have a small number of limited responses typically. Did you solve the problem? Yes or no? What is the square root of 16 plus or minus 4, right? Like, what is the name of this shape? There's not a lot that's going to come from that answer. It's a pretty simple, short response answer. There's like a correct answer you're trying to get at. Open questions invite more discourse. And we know there's been lots of studies on questioning in the classroom, and almost always the vast majority of questions are closed questions, without a doubt. And in my observations of classrooms, that is also the case. Most of the questions teachers ask and students ask are closed questions. So if you can start to open up your questioning a bit, you'll get more quality discourse. So how can you prove that the answer was correct? Like, that's inviting you to kind of explain your reasoning in more than just one word. What have you tried? It's not like a yes or no, or like one, maybe they said the calculator, right? That's very brief, but it does offer more opportunities, even if the students are kind of conditioned to answer very briefly. So we want to like kind of be conscious of closed and open questions and try to move toward more open questions if possible, because you'll get more discourse out of your students. The other way we think about it is product questions or process. Are you asking just about the answer, the solution, what you made, or are you asking about the process that got you there? Again, most questions in math classrooms are product questions. Did you get 5? What is the answer? What's your picture look like? That kind of thing. We want to ask more process, like how did you decide what strategy to use? Why did you or how did you decide to use a visual strategy? Did you consider thinking about manipulatives, things like that? So kind of questions around the process that got them to a product are really helpful. So instead of just closed product questions, we kind of want to move toward more open process questions, and it'll help you in the long run in your classroom. If you have a math coach, I know there's a couple of math coaches on the call. You might invite them one day just to sit in on your class and track. What are they seeing? Are they seeing like teacher-student interactions mainly? It goes teacher-student, teacher-student, teacher-student. Or are they seeing student-to-student interactions? Or are they seeing teacher to the whole class, like teacher oral response, teacher oral response? And then you can ask to kind of like get the questions cataloged. So you can kind of see what your tendencies are. As teachers, we develop patterns. I bet your kids know your patterns. If you ask what kind of questions, or if you say like, hey, if you're going to pretend to be me, which I don't recommend, but if you did, and they started to play, teacher in your voice, they would ask the type of questions they typically hear you do or the interactions. And you'll get a good insight into like what your patterns are, even when you're not fully aware of what they are. So asking a colleague or somebody to track some of these things for you is actually really illuminating. And it's not for evaluative purposes or anything. It's just to say, like, I wonder what my patterns are. I know when I listen to myself, if I were to listen to this webinar later, I know there's speech patterns that I have. I use so a lot. There's some others that I catch myself doing and I try to break, but they're hard to break because they're just patterns I get into. Questioning is kind of similar. So the more you know, the more you can be conscious of it and try to break those patterns. Ruth, we can give you a link to this document. Yes, I believe. And maybe Amy or Jose will be able to find it and link it in the chat. Okay, I just did a lot. So we talked about questioning, teacher's role, explaining math thinking. We're going to get at a little bit, but not as deeply. But the math talk moves help with that to get students explaining. Now we get to my favorite part, which is what are some things we can do as teachers to encourage more talk on tasks? And so we're going to get to some nudges on here. Okay, so we have instructional nudges. If you've not seen them before, we have a website that we've made for this project, and we also share them in the Math Matrix at times. This is an example. It's called Say What. And all it is asking at the end of a lesson or a set of problems, you have students clarify the main ideas either in writing or by discussing with their partner. Sorry, there's a typo there. So for example, we're going to show a video and you're going to kind of see what happens in this video. And these are, I think, kindergartners in this classroom. So it's a way of getting students to talk about what they learned. Because often we just go through things in the classroom. We never pause to reflect, what did we just do this about? Can you tell somebody else what this lesson was about? In this instance, we are going to look at a video where you can kind of see how one teacher took up this idea in their classroom. So this is a quick strategy to just have kids kind of share what they thought the purpose of the lesson is, or the main things, takeaways that they were to get out of it. And I thank this teacher for sharing with us. It's very nice that teachers open their doors to us and allow us to film their classrooms.
So this activity is called Say What. And what I want to ask you is, why do you think we worked on this today? What would you think the goal was or the reason for working on this math today? I want you to think for a second. Yes. We were to match our number sentence, right? What were we doing here? Were we trying to put things in order? Were we taking away? What were we doing? Oh my gosh, what does adding mean? What does that mean? Why aren't any of these crossed out? Think first. Why are none of them crossed out? Yeah.
Because it's not subtraction.
Because it's not subtraction.
I use say what at the end of lessons after we've talked about a concept and we've had multiple opportunities to practice so that I know they can verbalize what they just learned for that lesson that day. Based on these responses today, I need to review addition, the plus sign, the equal sign, and how the picture matches the addition problem they're trying to solve. Say what is fun. I think this is a great instructional practice to make sure your kids actually learn what you intended to that day.
So that is one way where it's a quick routine, it's a quick strategy. You're trying to get the kids to articulate, the students to articulate kind of what did they do that day? Because I can tell you, I will visit a lot of classrooms and then the students do all these great things. They're doing all these tasks. And then you say, okay, like, what did you learn today? And they can't really articulate, like they're like, we did problems, we learned math, but they don't really get the same main idea that they hoped of the lesson. So this is kind of one way that you can formatively assess and also getting the students talking. With older kids, or as you get more comfortable with this routine, you might have them build on, and you might have already been thinking as you watch that, oh, she could have had that kid add on or repeat their reasoning. So once you know about these math talk moves, you can kind of embed them into situations like this and get even more discourse and discussion out of your students. Okay, another one is in other words. And again, this is to get students talking about mathematics. Not all of these are going to result in a deep conversation. It's just starting to get kids to talk about mathematics in some kind of way. For example, you could have a problem like this or a situation like this, a prompt, and say, here's a topic or a term, a concept. Reword this definition using more common language or a different formal definition or another representation. So if I said to my students, area, and maybe I even give them the definition, the formal definition of area, you want to ask them, like, can you say in your own words what area means to you? What do you think of when you're thinking about area? So you're kind of opening it up to them to make sense of this concept and explain it in their own words. When they do so, you might learn, oh, their understanding of area might be a little different than mine or not as deep or nuanced. And that gives you opportunities to talk more about it, invite them to talk more and say more. So this is another quick way that when you have a definition, you might ask students, could you say in your own words? Can you write it in your notes in your own words? Can we explain it in a different way so that we're kind of getting a stronger concept of what this idea is? Three reads. I imagine many of you are familiar with three reads. If you are, you can give a thumbs up in the chat or, say a yes or something. But the three read strategy is one that helps us make sense of word problems or story problems. And story problems are really important to support discourse. Thanks, Stacy. So three reads is literally you read a problem 3 times. Each time you read it, you have a different focus. In the traditional 3 reads format, kind of read one is you're just reading to make sense. Like, what is this situation here? What's going on in this problem? That's the first read. Now, again, you can have a whole conversation about what the situation is about and use your math talk moves during that time. So that's just the first time because we really want kids to slow down, understand the task before they just start pulling numbers and calculating. So the first read is just, what is this situation about? And you can have a whole conversation about it. I seldom see teachers having conversations about the problem before kids start. And we know it's very important to do so for students' comprehension and also engagement with the task. The second read, you might focus on what values or information do you notice? What relationships do you notice? So you're kind of focusing in on some of the specifics of the task. So kind of read one is like, broadly, what is this about? What's happening? Read two is like, what quantities do we notice perhaps, or, things that are going on in the task? Are there relationships, etc.? So you're kind of getting at a finer grain size. And then the third one, you're kind of anticipating some strategies. Oh, what are some strategies that might help us answer this task? So that's a classic 3 reads. We're going to remix it a couple of different ways because students get into this too many times in the same process and they get bored with it. I get bored with it. So we're going to remix it a couple different ways. Remix number 1. You can still do 3 reads. You can also just do this 1 read if you'd like, but you do the task, you present the task, but you withhold the question. You don't actually show what they're trying to get at. So for example, Manny brought a cookie tray with 48 cookies to a party. On the tray label, it said a serving size is 1/12 of the tray. So there's a question probably that exists on this initially, but this strategy is you take out the question. Part of it is to try to slow down students and have them think before they act. But in the chat, if you want to, what is a question that you might assume or think would follow this prompt? So if Manny brought some cookies to the party, on the tray, it says a serving is 1/12 of the tray. What question do you think might be asked of this task? Any ideas? Marcia, how many cookies is a serving? That's probably where I would have gone to. Any other ones that you think? You can put them in the chat if somebody had a different question. How many people can you feed? Yeah, and then that would be a good conversation because you'd say, like, could we answer that question with the information we have? What information will we need to be able to answer that question, which would be a good one. Yeah, great. And that's assuming everybody eats the same amount. Do we need to know if there's a different number of people or something? That's an interesting one. Yeah. So math problems follow a genre. There is a genre of math story writing problem. I'm convinced that curriculum writers go through some course that teaches them because they all kind of look the same. It's like information, information, question. So kids are kind of conditioned to look for that, and they will likely come up with the question that was the original intent. But there's a lot of reasoning that occurs in just making sense of the quantities and anticipating what the question could be. So that's the first strategy. The second strategy is you could just remove the quantities. We know students like to pull the numbers and start calculating. If they learn about multiplication today, they will multiply on this problem, even if it's not a multiplication problem, because they're just so conditioned to being like, well, we're in multiplication, so I bet it's a multiply problem. So to eliminate a little bit of that, you could do something like this. You just remove the quantities. So Adriana has some pieces of candy to share. When she went to the park, she shared some pieces of gum. When she left the park, Adriana shared some number of pieces of bubble gum. How many pieces of gum does she have now? It's allowing you to then talk about what is the situation? What do you think is happening? What do you need to know? What do you think is going to go in those boxes? What kind of numbers? You could say, like, do you think it's going to be decimal numbers or fractions or whole numbers, things like that? And then do you have a strategy that you might approach? And they still can't pull numbers yet, right? So we're still talking in generals, which is nice because then once you give them the quantities, they'll start calculating. Yeah, like a numberless word problem. Exactly right, for sure. Yep, they're great. There's like so many resources on those as well. The last one is anticipating what the answer will be. So we want students to look at a problem and to say, when I solve this, I think I'm going to get an integer, or I think it's going to be a graph, or I think it's going to be a sentence because I have to explain my thinking with a number. We don't often ask students to anticipate what kind of answer they're going to get or they're aiming for. Even more kind of problematic is we have units in the original problem and then they just kind of disappear. Like it could be a whole nice task about bubblegum and things like that. And then at the end, the kids are just like 12. Well, then the context doesn't really matter. We're not using it meaningfully. We just kind of abandon it. So if you have kids kind of anticipate ahead of time, what is the form? What kind of answer are we going to get? Money, like decimals, fractions, graphs, equations, expressions, and then what kind of units does it have, if any? That's a really valuable strategy. There's some nice research behind this too that says it like increases the problem solving capabilities of the subsequent problem, which is nice. So here's an example of this. Rosa has 12 cups of condensed milk for her grandmother to make many batches of tres leches, my favorite kind of cake. So far, her grandmother has used 8 1/4 cups of condensed milk. How much condensed milk does she have remaining? So if you just say, we're not solving it yet, you be very clear with your students, we're not solving it yet. I just want to know, what kind of answer are we going to get? And what is that answer referring to? Like what unit is that answer going to be in? It's super valuable because you do a lot of thinking and you're trying to make sense of the context to get to what kind of answer you're going to get. So it's a good strategy. All right. Now, moving on from three reads. Say your students just did a worksheet with a lot of problems, which is common, right? Kids have to practice math. That's not a problem. What if you wanted to get more talk out of your students, though? So they just did all these problems, and you're like, well, we could just talk about the answers. I could just give them the answers. Or you could have them partner up and say, hey, you did all these problems. Can you tell me the two that you did that you thought were the most similar? And then do you think your partner could guess why you thought they were the most similar? So it's kind of encouraging students to think about what they just did and have a conversation about what they just did. So I know you're going to give your students problems to practice, like it's part of math, it's part of that procedural fluency. But how can we get them to talk about it a little bit with their students, their peers, and also do some reasoning and justifying and sense making? So this is a strategy we like. So if you want to put in the chat which two you think are the most similar, you can. For me, let's see, which ones do I think are the most similar? I'm not sure. Maybe 3 and 5 would be the most similar to me. So I might say to my partner, Jose, I thought 3 and 5 were the most similar. And so then Jose would have to try to understand and anticipate or guess why Xandra thought that 3 and 5 were the most similar. And he would have some kind of reason for saying that. And he might say, because they're exactly equivalent, because one is the simplification of 5/5 or something like that, 5/5. So, that's a way to get students to talk across problems. They might not all say the same thing. In fact, they usually don't. And that's good because then there's more conversation to be had. You could also do the analog of this and say, like, which two did you think are the most different and why, and have them proceed in that way as well. So the point is to get students talking about mathematics in a meaningful way. And we call that one pair and compare. All right, this is the last little set, I believe. And I hope this is the video I'm thinking of. So I'm going to play it and then I'll talk about it because I think this is the video that I love.
All right, we're going to play Say My Name, and we're going to take turns being the clue giver and the guesser, and then we'll switch. I'll have you start with giving the clues. I'll have you start with guessing. Are you ready? Okay. So hold that. Close your eyes, Bella. All right, put it on your head. Bella, you hold it. Go ahead.
It's a number. She's in numbers.
You use it in teen numbers. That's a good guess to help with.
It has a 4 and 1.
You know what number comes after it? What number comes after it?
15.
Okay, 15 comes after it.
14.
Good job.
So this is a way we talked about vocabulary earlier and how vocabulary is like key to a good conversation. The students are using it. This is a fun way, and I've seen teachers use this before. So it's like basically like the game fun headbands, and you put the terms or representations on a card, and you have the students describe it or guess it based on descriptions or whatever. So they're having practice talking about the concept to try to guess it, right? So they're describing it to their partner and their partner's trying to guess what number is on, or deduce, I guess, really, because it's not a guess, right? They have some information they're getting from the process. So kids love this. It always hits in the classroom. The students like to talk to each other. This was kindergarten students doing it. The teacher facilitated it in small groups. They're very small children. They were doing it for one of the first times when we joined them on this day. And then we're going to see some older kids do it next, I think. Yes.
Okay, this is a thing where it has 2 lines and it's never negative.
Parallel?
No, like
Oh.
around the equation, like it'll be numbers, and then like if there's 2 lines, it can't be negative.
Absolute value.
Yeah.
Perfect.
Okay, so imagine a shape with three sides, but
Triangle.
okay, you're on the right track, but only two of the sides are the same,
Two of the
like all
sides.
the same size and length.
Isosceles. Yeah. Yep. So imagine an equation, but like there is no solution. It isn't
Expression.
Yeah.
Okay. No edges, but is it a shape? It's not flat. It's a shape. No edges, but it's not flat. So it's like circular? It's like a 2D shape? No. What's the other one? A 3D shape? Yeah. Sphere? No edges. Yeah, sphere.
So you can see in that those are older kids, they were high school kids, but they're still engaging with it in a meaningful way. So you can kind of see what language they use to describe these things too, and what you might push on or think about like pushing further on in subsequent things. But they do a great job kind of communicating what's important to them and making sense of mathematics collaboratively. I think the key is I like to use fun, engaging activities to get kids comfortable talking to one another about math. Students talk to each other all the time, right? Especially in phone-free schools, which are increasing in popularity right now. And the students are talking to each other, but they're not necessarily used to talking about math. And when you say explain your thinking, what you have in your brain as to a high quality explanation may not be what they have. And when you say partner up and talk about math, you might not get a lot of valuable high quality discourse at first because they need strategies just like we need strategies to facilitate. So I find activities like Say My Name or some of those making sense of the three reads, story problem through three reads or variations on it are helpful because it lets kids start to use language publicly to talk about mathematics. They get comfortable with it and then the conversations get better. But it's like a skill. They have to learn how to do it. And these strategies kind of help students build those skills over time. Not Say My Name. Okay, well, we got to the end. If there's any reflections or questions you have, you can put it in the chat. I find it helpful when I go to webinars. I have little field notebooks that I take notes on when I do online classes or webinars, but you might want to jot down what you want to bring back to your colleagues or your classroom, or maybe after lunch you want to try something in your own classroom based on what you heard here today. Go back one slide. Yep. So if you want to write down kind of your ideas that you have from this webinar, and this will be posted in on our website in the coming weeks. So you'll be able to see the first one, like I said, and they will be on the website. If you have capacity, we are gathering survey data right now for a project we have on high quality professional learning. We're trying to understand more about how decisions about professional learning are made. If you're interested in participating, we'd love for you to either take it yourself or share it with a colleague. We will put the link to the survey in the chat, but any help you can do on taking the survey or sharing it is greatly appreciated. We will always share back what we learn from people that share their time and expertise with us. So thank you ahead of time if you're willing to do that. Our next webinar, lost the word for a minute. Our next webinar will be on math tests, my favorite topic, and that will be on March 24th. I did change the time because there were requests to change the time around, so I'm hoping this still works for those of you that were enjoying the lunchtime. If not, like I said, I promise I'll post them on the website. I won't, but Maxine and Hope will on our comms team. And so you will have access to it, but we love to have you join live. It's more fun to talk to people than just black boxes or just Jose, which Jose is a lot of fun to talk to, but I talk to him every day. So thank you for joining. If you have any questions, you can put them in the chat. Love to hear questions and answer them, and I'll stick around for a few more minutes. If you have to go, thank you for spending your lunch hour with us. We greatly appreciate it. So Take care. And if you have questions, put them in the chat because I will answer them.